Welcome students. We have studied that all materials around us are made up of matter. Any substance which occupies space and has mass is called matter. Matter around us can be categorized as pure and impure substance. Pure substance comprises elements and compounds. They were covered in the previous chapter. In this chapter, we will cover impure substances which comprises of mixture. Mixtures are not pure substances. That means mixtures are impure substances. In fact, they contain two or more pure substances, that is elements or compounds or both, mixed together in any proportion. Also, they are not chemically combined together. Mixtures can take many forms. We can have mixtures of more than two or more solids. We can have mixture of two or more liquids. We can have mixture of two or more gases. Combine or combination of solids, liquids or gases all together, but in any proportion. Many things that we see and use every day are a mixture of different things. Soil is a mixture of sand, clay, pebbles, wood and rotting plants. Rocks are a mixture of different minerals. Air is a mixture of many gases, mainly nitrogen and oxygen. Here are some examples: mixture of solids, mixture of liquids and mixture of gases. Mixtures are classified as homogeneous mixture and heterogeneous mixture. A mixture of sugar and water is said to be a homogeneous mixture. In a homogeneous mixture, the components are mixed together completely. That is, the components are uniformly distributed. There is no clear boundary of separation between the sugar and water particles in the mixture of sugar and water. Whereas in heterogeneous mixture, the components are not mixed together completely. That is, the components are not uniformly distributed, so they can be seen separately. That is, the components have a visible boundary of separation. A mixture of oil and water is another example of a heterogeneous mixture. That is, we can see two different layers. We can see the boundary of separation. Here, which kind of mixtures are these? We have got three examples here. Classify each type of mixture. Now here, cereal, we have cornflakes and milk. We can see the separate cornflakes and milk. They are not mixed together. We can see the boundary. So it is a heterogeneous mixture. Homogeneous, any juice, they are mixed together. If it is a mixed juice, we cannot separate the guava, orange, mango separately because it is one liquid and there is no separate boundary there. Third one, if we have got different pebbles, we can see them separately. So again, it is a heterogeneous mixture. So from here we understand that heterogeneous means, hetero means different, homo means same. So when we have different boundaries where it can be seen different phases are there, we call it as heterogeneous mixture. And if they are same, there are no different boundaries there, there are no different phases or parts, then we call it as homogeneous mixture. Homogeneous mixture. In this kind of mixture, you can't distinguish the components. Examples: puree, coffee, milkshake, chocolate, cold tomato soup, orange juice. Here, there is no clear boundary of separation between the components. Let's have a look at the heterogeneous mixture. In this kind of mixture, you can distinguish all the components. The components are not uniformly distributed, so they can be seen separately. The components have a visible boundary of separation. Examples: salad, milk and cereals, chickpea salad and so on. We just learned that a mixture can be a combination of two or more solids, two or more liquids two or more gases, or a combination of any of these three in any proportion and not chemically combined together. So here the best example of solid and solid mixture, that is a homogeneous mixture, is alloy, which are homogeneous solutions existing in the solid form. So alloys are homogeneous mixture of two or more metals or a metal and a non-metal that cannot be separated into their components by physical method. In alloys, the metal that is present in large quantity act as a solvent, and the other metal which are present in smaller quantities act as a solute. The components of an alloy are hard to separate. Example: brass is an alloy of copper and zinc, bronze is an alloy of copper and tin, steel is an alloy of iron and carbon. Solution: a solution is formed when a solid dissolves in a liquid or when a liquid dissolves in another liquid. A solution is a special type of mixture. A solution is a homogeneous mixture that combines a solute and a solvent. And let's understand what is solute and which part is solvent. The solid part that gets dissolved is called solute. Example: salt, sugar. They are solid, so they are called solute. The liquid part that does the dissolving, example water, is called solvent. Now here we have solute and solvent, that is solid as solute and liquid as solvent. A solution involves one substance dissolving in another substance, which is usually a liquid. A solution is therefore a homogeneous mixture. A solution containing water is known as aqueous solution. Let's take an example here. We just read solute is solid and solvent is liquid, and when they are mixed together we get a solution. So here we have taken salt as solid and water as liquid, and when salt is mixed in water we get a salt solution. In activity 1, to prepare a solution, we have taken sugar, sand, 2 beakers, water and a glass rod. Now here first we will take sand. If we take some water half filled in beaker and we try to put sand and stir it well and we try to mix it, can the sand particles mix with water? Do they disappear? No. Sand does not mix with water. Sometimes it does get muddy, but some of the particles, they do settle down below. Now take another beaker, fill it half with water and put some sugar there. Stir it well. Now can we see the sugar particles? No. Why? Because they have dissolved in the water. So the resulting mixture is called a solution. Let us understand the properties of a mixture. Some common properties of mixtures are: it can be separated into its components by physical methods. Second, the chemical properties of the mixture are the same as those of its components. That is, the components of a mixture retain their properties. Third, no energy takes place when formed. That is, no heat or light is taken in or given out. Therefore, no energy is released or absorbed when a mixture is formed. Fourth one, the substance in a mixture can be mixed in any proportion. The components of a mixture are not mixed in a fixed ratio by mass.